స్వాగతం కపర్ది మ్యాథ్స్ క్లాసెస్. గురుభ్యో నమః. This is your Murali Krishna. This is the 16th video on trigonometry. In this video and in the next two videos or three videos, I am going to deal with the concept, the trigonometrical ratios of multiple and submultiple angles. Let me explain first of all what is meant by multiple angle, submultiple angle. Okay, for example, I'll go for multiple angle first. Let A be any angle, of course of any size. Then n times of A, where my n belongs to Z, is called multiple angle. Of A. So my NA is multiple angle of A. What is the meaning of that one? That means suppose I have x is equal to, suppose say for A, angle A, for angle A, 2A, 3A, 4A, or multiple angle. Example, numerically, example, if A is equal to, say for example 30, then 2 times of 30, 3 times of 30, or 4 times of 30, or multiple angles. Of 30 degrees. Same way, what is submultiple? Submultiple means in the case of multiple, just we multiply, so here you have to divide. So let me write that also. Submultiple angle. For any angle A, angle A by n belongs to Z, that means integer, is submultiple. For example, A for A by 2, A by 3, or A by 4, all are submultiple angles. When you multiply, that is multiple. When you divide, that is submultiple. Now in this chapter, what we are going to learn? Now in this chapter, you have to express for any trigonometric ratio the value of trigonometric ratio of sin 2A. For example, sin 2A or cos 2A or tan 2A in terms of sin A. That means trigonometric ratio of multiple angle in terms of trigonometric ratio of that angle, that we are going to discuss. Again repeat, the value of trigonometric ratio of multiple angle in terms of trigonometric ratio of that angle A. Okay, now in this chapter also we have some identities Let me make a list of identities and let me prove identities one by one. Identities in this chapter. Number 1, basically 3, 6 are there. Let me make a list of this one. Sin 2a for any angle, A, number 1, sin 2a is equal to 2 sin a cos a. Next, cos 2a is equal to cos square a minus sin square a. Number 3, tan 2a, 2 tan a by 1 minus tan square a. And 4, sin 3a, 3 sin a minus 4 sin cubed a. Fifth one, cos 3a is equal to 4 cos cubed a minus 3 cos a. Finally, sixth one, tan 3a is equal to 3 tan a minus tan cubed a by 1 minus 3 tan square a. So, these are the 6 important identities. Now, I am going to prove these identities. There are 2 versions are there in the proofs of these identities. Number 1, the basic method board level. Number 2, the actual independent proof. Now, the normal method anyone can give. But here I want to give you the independent proof for all these identities. Of course, I am going to give you identity independent proof for sin 2u, rest of them is the normal things. For any angle, A, sin 2a, that means sin 2 times of a is equal to 2 sin a cos a. Now, in the first 10 to 15 minutes, I am going to give you independent proofs for all these identities. Okay, now the proof. Or you can say derivation. Let this is a circle. Let this is a circle. Let A be the diameter. Let C be the center. Let D is a point on the circle. Let angle DCD, BCD is 2A. Okay. So, in the circle, AB is the diameter. C is the center. Let P be any point on the circle such that angle DCD BCD is equal to 2A. So my next step is I join these two. Now this CA and the CD, the both are radius of the circle. When this angle is 2A, by plane geometry we know that this angle is also A, this is also A. Therefore angle BAD is equal to A. Okay, therefore angle BAD is equal to A. Now next one, what I do, I join these two. Now ADB is a triangle, and you know very well angle in semicircle is 90 degrees. Since AB is the diameter, therefore this angle must be 90 degrees. Must be 90 degrees. Okay, well this is A angle, and of course this angle is 90 minus A. 90 minus A. Shall I write that one? Yes, I write. Angle DBA is equal to 90 minus A. Next, what I do? I do one more construction. Draw a perpendicular line from D to the diameter. Say for example here. DN is perpendicular. DN is perpendicular. Draw from D to A. Okay. Since this is 90 degrees, if you consider a triangle BND, right angle triangle, this angle is 90 minus A, therefore this angle is equal to A. Okay. So in triangle DNB, angle BDN is equal to A. So construction part is over. Now I consider the triangle first. DCN. In the triangle, DCN or DCN, what is sine 2A? If I take, because I am going to do sine 2A, so I take sine 2A. So for 2A, this is the opposite side, and whereas this is the hypotenuse. So I do have for dn by CD or dn by go for CD. Right. Is my CD same as CD? Right? Because these two are right. So I take that one is equal to dn by, in the place of CD I am going to take CB, because CD and CB both are radian. So I have sine 2A is equal to dn by CB. Therefore sine 2A is equal to dn by CB. So I do here the small manipulation. I multiply both with 2. Now value won't change. In the place of 2CB, can I substitute AB? Yes, of course you can substitute, because AB is the diameter, BC is the radius. I can substitute. So I'll go for this one, 2 dn by AB. In brackets, if you want, I can write that 2CB is equal to AB. Yes. So I got 2 times of dn by AB. Now I do one more manipulation. Where is dn? This is my dn. Okay. Now I want dn, and dn is opposite to angle A. If I have AD, I can get a dn by AD is equal to sin A. So what I do, I dn by AD, I divide and multiply. That's all. So multiplying, dividing by AD. Now this dn by AD by AD. Like this is number 1. In triangle, ADN sin A is equal to dn by AD, right? dn by AD. Next one, AD by AB. Where is AD? This is my AD. This is my AD. Now, if you consider whole triangle ABD, my AD is adjacent side to angle A. Therefore, I consider big triangle ABD, and in triangle ABD, I have cos A is equal to AD by AB. Number 2. Substitute these 2 in 1. We get, therefore, sin 2A is equal to 2 times of dn by AD is equal to sin A times AD by AB equal to cos A. So we got the answer. Sin 2A is equal to 2 sin A cos A. Proof is over. Please take it. Next one, Cos2A is equal to cos square A minus sin square A. Construction diagram, everything is same, only I need to take cos. Now, in triangle, same triangle, in triangle CDN, I go for cos 2A. We have cos 2A is equal to Cn by CD. Here also I multiply both it to 2Cn by 2ED is equal to CB. I can write AB, I can write. So this is equal to 2Cn by AB, just like the previous one. Now I will focus on 2Cn. Look carefully. 2Cn is nothing but Cn plus Cn. What is, I add, subtract one quantity. What is the fun? For this Cn, what I do, I add AC plus Cn. For this one, I subtract AC. AC is same as BC. Okay, I do that one also. Plus Cn minus 1 more AC. Now, okay, R, I go like this. AC plus Cn, I take minus common. AC, in the place of AC, I can substitute BC because AC and BC both are same. So, I will go for BC minus Cn. Now, if you observe carefully, AC plus Cn, AC plus Cn is nothing but AN. So, I write this here, I will go for AN minus BC minus Cn is equal to Bn. I'll go back here. Bn. This is my construction. So finally, I have cos2A is equal to An minus Bn by AB by AB. Now here I do one more multiplication. An, where is An? This is An. My An is adjacent side for angle A. If I have AD, I can write as cos. So what I do, I multiplied An by AD times AD by AB. I'll go Bn by, that part is later, A. Let me focus on this first one. Now An by AD, AD by Bn. Next come to Bn. Where is Bn? This is Bn. My Bn is opposite to capital A. This angle. My Bn is opposite to A. But if I want to convert in sign, I want to multiply with the BD. So here also what I do, multiply with AB by Bn. I write here Bn by BD times BD by AB. So here I multiply with the AD. Here I write AB and BD. Now focus on An by BD. An by BD is equal to cos A from triangle AND. I am not writing that one, straight away I do cos A times AD by AB. Where is AD? Yeah, this is AD. AD by AB. AB. The whole triangle AD by AB will become again cos A. So I will go one more cos A. Minus Bn by BD. Just now Bn is the opposite side to A. Therefore, I can write as sin A. BD by AB. BD by AB. Now BD by AB again sin A. So this is equal to 1 more. Therefore, finally I have cos square A minus sin square A. Yes, I got proof for cos2A is equal to cos square A minus sin square A. Please take it. Next one, tan 2A is equal to 2 tan A by 1 minus tan square A. Put here. Diagram is same. Now, same triangle. For sin 2A, I had taken CDN. For cos 2A also, CDN. Even for tan 2A also, CDN triangle only. In triangle, CDN, we want tan. So tan 2A is equal to opposite side, that means DN by Cn. Here also I multiply, divide by the 2. Same thing. So here also 2dn by 2cn. Now in the place of 2cn, we have written an minus nb. So I will do same thing, right? 2 times of dn by an minus n. I do one more step. I divide both sides with an because here I have 1. So what I do, 2 times of dn by an over 1 minus nb by an. That's all. Now one more step. I don't have any problem with the dn by an, ready made again. NB, here I have NB. NB is opposite to this A. If I have dn, I can write NB by dn is equal to cos sine tan A. So what I do here, I don't touch the numerator, dn by an, but as this, by 1 minus NB by dn, and here also I have dn by an. So I multiply divided by dn. Next one, NB by dn is equal to 1 by value dn by an. dn by an is nothing but tan A. So I got a 2 tan A in the numerator by 1 minus NB by dn. NB by dn from this triangle again tan A. And what is this dn by an? Dn, where is dn? Yes, dn. This dn by an again cos A. Sorry, again tan A. So this is equal to, we have 1 more tan A. So finally I got 2 tan A by 1 minus tan square. Proof. So these are the 3 independent proofs for sin 2A, cos 2A and tan 2A. Again I am repeating, if you are thinking only at board level, don't break your head to learn these proofs. We have another type of the proofs also, you can learn that way. And if you don't want to learn this one, just skip this video and go to the next one. We can prove these same identities in using another method also. That method is by using compound angles. Let me prove them. So sin 2A is equal to 2 sin A cos A. I am going to give you a very simple proof in one line. Consider sin of A plus B. Already you know what is the formula for this, that is sin A cos B plus cos A sin B. Now here I want 2A. So what I do, replace B by A. So what do we get? Sin of A plus A is equal to, we have sin A cos A sin A. Now if you observe carefully, this is nothing but A plus A 2A, and this is sin A cos A sin A cos A. So we have 2 sin A cos A. That's all. Next one, cos 2A. Cos 2A is equal to cos square A minus sin square A. So here, to get this, consider cos of A plus B. Cos of A plus B is equal to cos A cos B minus sin A sin B. Technique is same, put B is equal to A. So we have or cos of A plus A is equal to cos A minus sin A sin A. So A plus A is 2A, we have cos 2A is equal to cos A cos square A sin square A. So we get cos square A minus sin square A. Same technique for tan 2A also. So tan 2A is equal to, we have 2 tan A by 1 minus tan square A. To prove this, consider tan of A plus B. Consider tan of A plus B. Tan of A plus B is nothing but tan A plus tan B by 1 minus tan A tan B. Now replace B by A, we get tan 2A is equal to tan A plus tan A by 1 minus tan A into tan A. So tan A plus tan A is 2 tan A by 1 minus tan square A. We got it. So this is the proof of these three identities using compound angles concept. Okay, please note down. I need to derive some more identities from this one. We have some more identities. Number 1, sin 2A, already we know one identity, that is 2 sin A cos A. We have another identity, that is 2 tan A by 1 plus tan square A. Proof. So proof is very simple. From this we can derive this. So sin 2A, proof, sin 2A is 2 sin A cos A. We know this. What I do, I write 1. In the place of 1, I have a relation between sin and cos, that is cos square A plus sin square A. So write this 1 as 2 sin A cos A over, in the place of 1, simply you write cos square A plus sin square A. Now I want to tan A here. What I do, I divide both numerator and denominator by 2 sin A cos A by cos square A by cos square A plus sin square A by cos square A. So what is my operation? Dividing both numerator denominator by cos square A. Now if you split this, 2 sin A cos A, 1 cos A will get cancelled. So we have 2 sin A by cos A by cos square A by cos square A 1, cos sin square A by cos square A. So we have sin A cos A whole square. Now replace sin A cos A by tan A. So we have 2 tan A by 1 plus tan square A, hence proof. Finish. Similarly, in the case of cos 2A also we have cos 2A is equal to, we have number 1 cos square A minus sin square A, number 2 2 cos square A minus 1, number 3 1 minus 2 sin square A, number 4 1 minus tan square A by 1 plus tan square A. So based on the situation, you can use in the cos 2A as either cos square A minus sin square A, 2 cos square A minus 1, 1 minus 2 sin square A, or 1 minus tan square A by 1 plus tan square A. Of course, all these next 3 are derived from the first one. So I will take the first one, already we proved, proof. It is very simple proof. Cos 2A is equal to, we have cos square A minus sin square A. I want in terms of cos, so remove sin by using the identity. What is that? We have cos square A minus 1 minus cos square A. If you simplify cos square A plus cos square A, 2 cos square A minus 1. Now I don't want cos, I want sine. So convert cos square A in terms of sine square A. We get 1 minus sine square A minus sine square A, or 1 minus 2 sine square A. Either this or that. Finally, how I can get this one? Same thing, I will take help of this. Cos 2A is equal to, we have cos square A minus sine square A by 1. Same technique here also. I write this 1 as cos square A minus sine square A, this 1 as cos square A plus sine square A. Now I want 1 and 1 here, so I remove the cos square by dividing both the numerator and denominator by cos square A. So when I do that, I will get 1 minus sine square A by cos square A, I will get tan square A by 1 plus tan square A. So I can use either first one or second one or third one or fourth one for cos 2A. Please take it. Sin 3A is equal to 3 sin A minus 4 sin cubed A. So for this, consider sin 3. I can write sin 3A as sin A plus 2A. Now open the bracket by using compound angle formula. That is sin A cos 2A plus cos 2A sin A. Now sin A cos 2A plus cos A sin 2A. Now I don't want cos terms, I want only sin. How I can do? Look here, very simple one. Sin A, I have cos 2A as 1 minus 2 sin square A, just now we derived, plus cos A, and the sin 2A is nothing but 2 sin A cos A. Again open the bracket, sin A minus 2 sin cubed A plus this cos A and cos A, cos square A. So in the place of cos square A, I can write 1 minus sin square A. Now open the bracket, you have sin A minus 2 sin cubed A plus 2 sin A minus 2 sin cubed A. So we have sin A, 2 sin A, it's nothing but 3 sin A, 2 sin cubed A, 2 sin cubed A, so 4 sin cubed A, that's all. Similarly, we have cos 3A, one more. Cos 3A is equal to, we have 4 cos cubed A minus 3 cos A, same identity. Similarly, for tan 3A we have tan 3A, 3 tan A minus tan cubed by 1 minus 3 tan square A. Proof is same. Write 3A as 2A plus A, go for tan of A plus B formula, then replace tan 2A, you get this expression. So we completed the derivations of all multiple submultiple related identities. Please take it.